Completed scaling, gradient, and L1, L2. So resampling technique. And so in grid search CV, we have something called CV. CV stands for cross validation. Basically, when we provide this trained data set to this, it is going to divide this whole data set in 10 chunks, 10 parts. Suppose if a trained data set is like this, right? Then if we have 10 x equal CV equal 10, it's going to divide this whole data set into 1, 2, 3, 4, 5, 6. How many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is divided into 10 sets. Suppose if we give 5, this whole data set is going to divide into 5 data, 5 subsets. And this sampling is basically, related to that. In this one, it is going to use k-fold cross validation. This one. Trained data sets we already have seen, right? How to divide this into trained test split. So here we use trained test split. So the same concept over here. Trained test split, trained and test data sets. So if we give test size as 0.3, what does that mean? Trained set is going to be 70%, 70.7, that is 70%. And there are a few other techniques which we don't use it in real time, but as we have to discuss this resampling techniques, I'm going to give an example for each. So what is this trained test split? Why we need it? Unless we keep the test data set aside, it is difficult to judge what is the accuracy of the model, right? Isn't it? So that is one way of that is one reason why we keep that 30% whatever. So we use we separate X and Y, all the input columns into one data set, another one, and the target is going to be another one. We use train test split, and as we not to provide train size, so we need to provide only test size. Based on test size, the remaining part is going to be for training. So it's going to help us in getting 4 chunks. I think we discussed this part, the Michelin template itself. Whole data set is going to divide into 4 parts, right? We have data set like this, if we have target variable, this is going to be Y, and the remaining is going to be X. And when we divide this in, let's take 0.3%, this is going to be X train, this for training, this for testing. So this is X train, this is Y train, this is X test, and this is Y test. So that's exactly what this component's all about. With the help of train test split, we get that one. And
So what is a random state?
yeah, I'll explain the random state later.
Okay.
The k-fold is basically, what this CV does in this case, CV equal to 10. Yeah. So internet is going to use k-fold. What is k-fold? K-fold is basically again kind of train test split. What it does is for regression problem, it is going to divide this into 10. The CV, if when we give CV equal 10, it is going to divide into 10 chunks. Okay. And when it divides the data set into 10 chunks, what happens is, and it's going to be part of training. So the one data set is going to be kept aside. I have issue with mouse one second.
It's going to divide it into 10 chunks means sampling the data itself.
So the whole data set is going to be in 10 chunks. So what is our bringing sampling here? We're going to reshuffle once. I think the mouse got disconnected.
So you're not audible.
The mouse got disconnected. I'm connecting it once.
Yeah, okay.
So we divide into 10 chunks so that internally, when it goes through this training process, basically we get the model, right? But internally what happens is for 10 chunks, when we provide 10, when divide into 10 chunks, it's going to generate 10 models. For each algorithm, it's going to generate 10 and 10 models. What does that mean? So let's take that in the first loop, it's going to go through 10 loops. If we mention 10, if we mention 5, it's going to go through, it's going to divide the data set into 5 chunks. It's going to go through 5 loops. So the initial first set is going to be for testing. And the remaining part is going to be for training in the first loop. And then second loop, the second set is going to be for testing. The remaining part is going to be for, remaining chunks is going to be for training. And so on and so forth. It is going to be 10 loops. So it's going to generate 10 models. And whichever the best model out of these 10, that is something that is going to reflect here. So this one is not really one model, it's 1 out of 10. Got it? What the CV does. So in fact, we call it as K4. So if you want to apply it directly, you can use this method. Or else Gridsa CV internally is going to use K4 when you mention CV equal to whatever the number. So you don't go beyond 10. When we have very little amount of data, then you can reduce the number, but don't go, and it's too little or too large is not good. Any questions on this part? K4?
Sir, just not a question, just I need to recap. So if I get the data set, then in previously what we are doing, we are splitting the data in train and test.
No.
But
See, recollection is different. You can go through, practice and raise question. But if you have any specific question, you can raise it.
no,
So
sir. With respect to this one.
This one only I'm telling you that if everyone start recollecting it, then what happens? So my suggestion is request you to raise specific questions. When it comes to practice, watch the video. And if you still have questions even after practicing it, after watching video and taking notes and practicing it, you can always raise questions, but don't try to recollect things. I can understand your perspective. If it is one-to-one, I always encourage. When we have too many people, then it's going to be very difficult if everyone starts recollecting it. If you have questions, specific question, let me know. Okay? Hope you can understand what I'm trying to say.
Yes, sir.
Okay, any questions on K4?
No.
The next one is, if it is classification, the way it works is going to be quite a bit different. It's the same thing. So there won't be any change in the code in the class, even the classification. The same grid says CV equal to 10 or whatever. The only difference is, sorry, the only difference is when it comes to the target column, that Y column. So let's take that we have Apple, okay? Apple, if let's consider that this is the data set that we have, and the target column has these values. Okay, I'm not mentioning the input columns here. It's focusing on target column. Let's consider this is these are the labels. And how many rows we have here? 1, 2, 3, 4, 5, 6, 7, 8. Out of 8, how many are banana?
5.
5. Okay. Banana are 5. What about apple?
3.
3. So basically, we have more bananas and less number of apples. When it reshuffle, basically when we mention CV equal 10, what happens is it's going to reshuffle the whole data set and it's going to divide this into chunks, isn't it? Let's say if we give here this very little data set, right? Let's say CV equal 3, it's going to divide into 3 chunks. Then how it's going to be at the end? Like for each chunk, it's going to be like, ignore the input columns. Of course, it's going to have, yeah, the grid cell CV has to have the input data, right? But target, just focus on the target. How the data is going to be. The first chunk is going to be.
I mean, the number banana and apple, the numbers will be same, but it will be reshuffled. That's it, right?
Yeah, just obviously it's going to reshuffle. Just consider that it is not reshuffle and how the values are going to be. It is apple.
Apple, banana, banana.
And as we have taken CV equal 3, or else we will do nothing. We will take 4. Or maybe 2 itself. I think 3 is better, right? Okay, so we'll go with 3 itself. So apple.
Banana.
We'll divide right here itself. What about? So it's going to be like this. Just it is going to reshuffle, but just assume that it is not reshuffle. Even after reshuffle, that this is what we got. And for each chunk, this is going to be the these are the values we have, right? Let's consider this another banana. Now the problem is when it trains on this data set, considering this as a test, then what will happen? What will the consequences?
Totally it will be biased.
Biased banana. So when the model we got here is banana, and it's going to judge on a totally different rows, which has no all apple. So it is not going to yield out well. Whereas in the classification, what in a CV does is K-fold is going to be stratified K-fold, not regular K-fold. It automatically does that, so we not to bother about it, but we need to understand the logic behind it. So when it reshuffles, in this case, it is how much percentage? 60% we have bananas, and I can say, yeah, 66% bananas and apples are 33%, right? It will make sure that in each chunk, that 33% is going to be apple and the remaining are going to be banana. Okay. I hope you're getting the picture now. So in classification, what the CV does is not going to apply K-fold. For regression problems, that's fine. So we not to balance this in each chunk, balance this class in each chunk. In fact, regression, we're not going to have any classes. Only classification will have classes. K4, that's regular. So we're not to bother about balancing it. Whereas start for K4, it will make sure that whatever the percentage of rows, labels we have, for each chunk is going to have the same percentage as much as possible. Of course, if we don't have any value here, obviously this is going to be banana, right? Yeah, that's it. So I hope this is clear. So any questions on stratified K4? Then it is going to yield out better. Is that clear? Stratified K4 and K4. All right. The next one is leave one out cross validation. The same K4 logic, but instead of dividing it to 10 batches, each row is going to be like, it's going to be like one row. First row is going to be for testing. The remaining rows are going to be for training. In the second loop, second row is going to be for testing, and the remaining rows are going to be for training. And in third loop, third row is going to be for, and I'm referring to the batch, but it's actually consider that these are the number of rows. Okay. The third row is going to be for testing, and the remaining rows are going to be for training. Got it? So leave one out cross-validation. If you have million records, then it's going to go through million loops and it's going to generate million models. So we don't use this methodology in real time. That's the reason you are not going to have this in template. But there is one option as such. So I have given it as a separate file.
So for the respective loop, respective row will be considered, right? For the
Yeah,
test
there
case.
are all the rows, the remaining rows.
Oh,
It's not going to leave out any rows, at least either for testing or for training. But for every row, it is going to be quite tedious and it's resource intensive. When we have a small data set, that's fine. But when we have a large data set, then this is going to be kill the system. All right. The next one is very much like trying to split, but it is repetitive. So it's more of like, the same trying to split. In fact, it is almost like K4, but instead of dividing this into, let's take that. I can say the repeated transport is going to be like just trying to split. You know what is trying to split, right? So we are going to, if I mention test size equal to 0.25, what does that mean? The remaining data set, 75% of data is for training. Train size is going to be for 0.75.
fine.
So when we keep on repeating this, what does that mean? So like we have 0.25, right? So 0.25 means the total data set is going to be divided into 4 chunks, 4 batches. 25%, 25%, 25%, 25%. Okay. Then in first loop, first part is going to be for testing. The remaining parts are going to be for training. Second loop, second part is going to be for testing. The remaining parts are going to be for training. So it's based on the percentage. Got it?
Yep.
Suppose if you have 100 rows, 25% means
25
what?
rows.
25 rows. So it's going to repeat it, it's going to keep on repeating, right? Let's take 25
So
rows, 25 rows, 25 rows, 25 rows, right? The first loop is going, this is for testing, the remaining is going to be for training. Second loop, this is for testing, the remaining rows going to be for training, and so on and so forth. When it comes to K4, it is going to divide this data set into, let's say if we mention 10, it's going to divide into what?
10.
10 rows. That's the difference. It's a proportion, it's based on proportion, it's based on the number of row, by divide by, kind of. It's almost same, not exactly. That is what repeated random test train spreads does. Yeah. Any questions? Go ahead. You're saying something.
So all these are like for the testing of the cases, right? For which case is suitable for that one, finding out that one.
So basically, generating model is not one like applying algorithm generate the model. So we need to go through all these things to get the best model. Even without applying this, we can get the model, but may not be good enough. That's the idea.
So which are the sampling? I mean, as you told, all this method sampling has to be applied.
Again, where are you going back?
I mean, this one.
Okay. It's
So
sampling.
for every data set, do we have to do, I mean, all this to get the accuracy or something like that?
So this will take care of everything. So the grids are saving. This template will take care of it.
Okay.
And here we have n jobs equal to -1, right? N jobs equal to -1 means, let's take that in my system, I have 24 cores, that two logical processes, right? So if you mention -1, it means that when I run this script, what is the script does? It is going to train on the data to generate the model, right? It's going to fit the algorithm on data that's going to in order to get the model. So whether it has to utilize all the processors or a limited number of. When I mention -1, it means that it's going to utilize all the processes. What if I mention 4? It's going to utilize only 4 logical processes. How it's going to be useful? Suppose you're running on a server. Some other application is going on, some other application is running in the background. So when you mention -1, what happens? That will stop working, isn't it? Or there will be some conflict. So always we have to have a system wherein it has to be dedicated only for training, nothing else. That is recommended. What if you have a process that is running, and in such case you have to parallelly run the training process, the fitting process, to get the model. In such case, go with this change. So you can, let's say 12, then it's going to utilize only 12 logical processes. In this case, 32, right? So it means 20 processes are going to be kept aside for other things. But highly recommended to use only -1. Have to have dedicated mission. Is this clear?
Yeah.
Yes, sir.
Okay, the next one is the random state. You will see this frequently. You can see random state here and random state somewhere else, right? Even trying test split, we have seen random state. So what is this random state is all about? So when we have random state, basically means that this mechanism is going to reshuffle. Whatever the data set that we get here, it is going to reshuffle. So, and even in this case, whenever we use this one, so the data make pipeline will make sure that data get the algorithm by itself is going to reshuffle the data. But the problem is that, let's take that I have given you a question paper to you and ask you to write answers, right? And another guy, I have given another question paper, not exactly the kind of question that you got. Maybe simple, and in your case, it is complex. So let's take that you got 75 out of 100, the other guy got 95. So is it reasonable to say that you have performed much, lower than the other guy?
No.
Because the question paper that I have given to you is quite different from
Other than
the other question paper given to the other guy. So we need to make sure that we give the same data set for all so that we can compare it. Because we don't know which algorithm works well to the data that we got. We have to apply all the algorithms. But when we provide data to algorithm, it's going to reshuffle. Whenever it reshuffles, every time we provide data to it, then this will have a different data set, and this will have a different data set, and this will have a different data set. Altogether, it's going to mess up. How can I seed it in a way that all the algorithms will get the same sort of data set, even after reshuffle? That is when this random state comes in. Okay, this random state can be any positive number that includes 0. It need not be 1, 2, 3. It can be any number. So the idea is, as long as you give the same number, it doesn't matter 1 lakh or 20 lakhs or or just 5 or 0. It should not be a negative number. So as long as you provide a positive number that includes 0, and you maintain the constant value across all, then it's going to maintain the same data set across all the algorithms. Got it?
yes.
Even the same case for trying test split. So when the advantage of having, because here we are not comparing with any other, right? Because we are not just it's one-time execution. We have used this one because when you re-execute with the change in the parameters, when you in the first block you keep on changing the values, right? Whenever you keep on executing it, you compare it one to another, isn't it? At the end, here you're going to compare it. So you keep on changing the values here. Then how come how come we compare one to another when it keep on reshuffles, isn't it? That is why we have this trying to speed random state 1, 2, 3, 4. So when you execute it again, run all after changing the first block, it is going to give you the same data set. And again, the third loop is going to give the same, make sure that the shuffle data set is going to be the same so that we can compare it, isn't it? Now, basically, this random state in the make pipeline is to compare one algorithm to another algorithm, make sure that data is common for all the algorithms. Now, the trying to split to random state 1, 2, 3, 4, and can be any number, is like, when we keep on changing the values and we compare one to, like in this case, I got 94.4. After making changes, let's take that I got something else. So I'm comparing one iteration to another iteration. One set of things to another set of things, the same script. Got it?
Yeah,
Why we use random state 1, 2, 3, 4. Or it can be any other number, but I try to give a unique number compared to what we use it in make pipeline. That's the only thing. It can be any number, as I told you before. It should not be any negative number. As long as it's possible that includes 0, it works. Don't bother about what is the 1, 2, 3 or 1, 2, 3, 4. It has to be 1, 2, 3, 4, 1, 2, 3. No. It can be any number
positive.
as long as it's constant across all. And train test speed is totally different process, different thing altogether. So we can give any number you want.
Yeah.
All right. So what else we imbalanced data set. There is another important one. I think we have taken example here. In this case, it's clearly imbalanced, isn't it? Around banana are 5 and apple are only 3. So when overall, even though I haven't mentioned earlier, overall, when we train on this data set, basically the typical tendency of any algorithm is it is going to tilt towards the high number of classes. Whichever the class that has high frequency. In this case, just imagine that apple we have only 2, and banana we have around 100. What will happen? Then the algorithm is going to generate a model in a way that is going to be tilted towards banana. Doesn't matter what we provide, it's always tilted towards banana. How do we how do we solve that problem? By balancing it. That is when this imbalanced data set comes in. So when we have classes in a way that these are completely imbalanced, what does that mean? The number of classes is number of values that for a particular class is completely different from the other one. If it is 98, 95, or 95, that's fine. Not to really bother about it. When it is something like 10 out of compared to other class which has 100, obviously this model is going to be not good enough because completely tilted towards banana. So we need to balance it. There are two things: oversampling and undersampling. Never use undersampling, even in template, in classification template, you will see oversampling. So the difference between, you can see that the difference is initially it was fraud label as 492 and normal label is 2,84,315. Okay. After balancing it, of course, we import the algorithm. It's like an algorithm. We create object and then we apply fit resample and we get this data set. So we are going to use this data set at the end. But point is, you can see that compare these values. 490 initially is 492 2,84,315, and thereafter it got 5,67,560. This is oversampling. This is undersampling. Undersampling got what? 490. One second, I think this got. I think last time I executed it, it took a lot of time, so that's the reason I stopped it. It didn't reflect. So what happens is like it's going to cut down to 492. This one, undersampling is going to cut down to 490. What does that mean? We are going to lose a lot of data, isn't it? From normal. Oversampling is the same rows being keep on adding to make sure the number of classes that this particular class has normal is going to have as many classes as this one. We need to balance that. I hope you're getting the picture now. So now this one is basically the computer removing the number of rows to get to the shape of this fraud. So this is 492. So it's going to cut down to around 492.
cut cut down to means it will drop the
Yeah, it
data.
will drop the rows related to the normal class,
Okay. To equalize that one.
but which is not recommended, right? Because we're going to lose a lot of data.
Data, yeah.
So that's the reason I have not used that option in template, but I have used only oversampling, even though it takes a lot of time. You can see that in this data set itself, I think it has a lot of rows, of course. It's going to take a lot of time. If you look at this one, you can see that it's completely full. 99% utilization. We'll allow this to get complete and we'll see the output. We started at 8 o'clock, right? 9 o'clock.
Yeah, 9 o'clock.
9 o'clock.
The reason why I ask you to know keep on utter the purpose of the block while executing the project is when I say oversampling, you should be in a position to keep referring to that one. So I should not go again to the template and keep on referring to the same thing. Okay. Oversampling, you can see over there, imbalanced data set. I've used the same logic, whatever I have written. Okay. So there are few changes here and there. I may not use xres yres. I may reassign it to xtrain and y. Xtrain equal to xres, ytrain equal to yres to change the actual data set. You can see 5,67,000, and this one is 984 only. So basically, it has been duplicated, and the 492 plus 492 it has added to 492 rows, same rows, and this one for 2,84,015. 2,84,315. How much data we have lost? 984. 2,83,331. It's insane. Only difference is the way you import the IMB learn. In your case, it may not be installed. So you need to go to terminal, pip install IMB learn. Smart Tomek, that is the one that we use to for oversampling, whereas in the case near miss is the one that we have to use for undersampling. It's part of undersampling component. This one is part of combined component. Any questions?
No.
So if those who haven't practiced the project well, I request you to practice as much as possible. Okay.
Okay.
Decision tree, shall we continue tomorrow or shall we discuss it now? All right, we'll continue tomorrow. Yeah, decision tree, hyperparameters, we'll discuss it tomorrow. We have metrics also, metrics and page selection on some algorithms.
Principal component.
That is part of clustering. We will discuss that at the end of the course. So that is not really required much. Anyway, generative AI will have that clustering mechanism. We'll see that later. So complete feature selection matrix, decision tree, hyperparameters, ensemble. Yeah. Okay, that's it for today. We'll continue tomorrow. Any questions? You'll slowly start getting picture of the whole template. The parts that you feel that you have missed, by the end of machine learning internals, you'll get complete idea. These are metrics. So we'll see that as part of metrics. Okay. All right. Thanks for joining.
So how can we understand to write this all scripts? I mean,
so that's the reason I have written, right? So it's you can write your own, but that takes a lot of time. From myself, having more than 6 years of experience, I've taken almost a month time to complete the script. Basically, the idea is to for any beginner, pick it up and generate the model. So try to generalize the whole thing. It's not easy. Write a script like this.
So if you're applying that one, so if they tell us to write the same thing, right? So what you have written?
It will take a lot of time. Yeah. You need a lot
So
of
how,
experience.
I mean, how to learn this? I'm asking, that's it.
You learn Python, you learn pandas,
Mm-hmm.
then you are seeing how to import this all, right?
Mm-hmm.
So and if you ask me how to remember and how to rewrite it, it's how much practice you do, it all depends on you.
Mm-hmm. So this is the template that everyone writes. So just understand and copy that one. That's it. Like that.
It's not everyone writes, it's there, like every individual has their own way of doing things. So I'm trying to keep everything into one script in a way that even a beginner, those who take my course, can able to execute the project and can generate a very decent model. 94.9% accurate model or any data set that you take, it is reasonably good enough. Especially being beginner, that's the reason I mentioned it is at least you'll get 2 years of experience. Reason for that is these sort of templates will help you to generate good models. So much so that a 2 year experience guy can generate.
Okay.
All right.
Okay, sir. Got it.
Thanks. Thanks for
Thank you.
joining. We'll
Thank you,
meet
sir.
tomorrow.